Now that we have talked about function notation, we can go ahead and look at how to find the domain of a function algebraically. First off, whenever we are looking at the domain of a function algebraically, what we are going to do is we're going to start with the largest amount of values that we could possibly think of and narrow it down. So we're going to look at the largest set of allowable values of our independent variable, usually x. Two good things to look out for are fractions, and we never want to divide by 0, so we'll look at what values will make the denominator 0, and we'll exclude those values. Then we'll look at even indexed radicals like square roots or fourth roots, and we never want to take the square root or fourth root of a negative number. And the reason why we don't want to do that is because the square root or the fourth root or the sixth root of a negative number is going to be not real. So here we have a function and we want to find its domain. So notice we have a fraction, and in a fraction we don't want the denominator to be 0. So what we will do is let's set the denominator equal to 0. So we have 6x squared plus 7x minus 20 equals 0. Now, you should be able to solve this, so pause the video and check your algebra skills. See if you can solve this. So hopefully you paused the video and have tried to solve this. First line of attack could be to try to factor it. So if we try to factor this, 6x squared can be factored into 3x and 2x. Our negative 20 will have to be factored into different signs. So if I try 5 and 4, it would make sense not to put the 4 with 2 because it would share a common factor. So I'll put the 4 over here and the 5 over here. And if I try plus or minus, notice we get 8x and negative 15x. That gives us negative 7x, which means that we have the wrong signs. So let's go ahead and fix that. This should be 3x minus 4 and plus 5. So 3x minus 4, 2x plus 5. Don't forget this equals 0. If we check this out, it will indeed FOIL into the 6x squared plus 7x minus 20. You could have used the quadratic formula, but it is not necessary to do so here. You will obtain the same values though. So 3x minus 4 equals 0, or 2x plus 5 equals 0. So x would equal 4/3, or x equals negative 5/2. Now either of those two values is a solution to the equation, which shows that the denominator would be 0 at those two values. So what we need to do is we actually need to exclude those. So we don't want either of those values to be allowed into our function's set of inputs. So the domain will be everything from negative infinity up until our negative 5/2, and then everything from negative 5/2 to 4/3, and then everything from 4/3 to infinity. So now let's look at maybe what you could consider a simpler function. G of x equals 3x squared plus 2x minus 1. Do you have a guess as to what the domain of this function would be? Well, if we think about all the things that are being done to our input, we're squaring it, then we're multiplying by 3, we're adding double our input, and then we're subtracting 1. Are there any values that we cannot do these things to? Is there any value that we cannot square? In other words, is there any value that we cannot multiply by itself? If you give me a number, is there any number you can give me that I cannot multiply by itself? No, I can square any number. And then I can always multiply that result by 3. I can always double the number. And I can always add those two results together, and I can always subtract 1 from anything. So therefore, the domain here is going to be all real numbers. Nothing gets excluded. So negative infinity to infinity. Now for our last example, we have the square root. Notice this is an even indexed radical. It's a square root. So we want the radicand, the thing that we're taking the square root of, to be greater than or equal to 0. We do not want it to be negative. So 4 minus 2x must be greater than or equal to 0. So let's use our abilities to solve an inequality here. Let's subtract 4 from both sides. Now we divide both sides by negative 2. So if I divide the left-hand side by negative 2, we get x. If we divide the right-hand side by negative 2, we get positive 2. But we divided by a negative, and so we switch the direction of the inequality. So we want all the values to the left of or equal to 2. So we're looking at negative infinity all the way up to 2, and we can include the 2.